Hello, good morning to everybody. This speech is not scheduled, is not included in the program, but the scheduled speech is not available because the company cast is unable to attend today the meeting. For this reason, I introduce my speech about this specific theme. Is a research project developed through a collaborative partnership to advance knowledge of material for LH2 application. My name is Francesco Apuzzo. I'm the Research and Development Manager of Carrara SPA. I'm the President of VALVEcampus, the association which organizes all conferences in this exhibition. So, the question is what happens at 4 degrees Kelvin under LH2 condition? And the available literature on the behavior of plastic material in cryogenic application is extensive for condition at minus 195 Celsius, is the nitrogen, liquid nitrogen, but quite limited to condition at 269 Celsius, is the hydrogen liquid temperature. Considering future industrial development, it's therefore important to increase our knowledge about the behavior of the involved material adopted to make a sealing under LH2 condition. The first reference found in the literature about test for to qualify polymeric material at LH condition is dated 1917 from NASA Spacecraft Center, Houston Center. And the program is planned in 3 different phases, and this report is a part of a complete report, is a public report available for everybody. Was conducted to identify and characterize material which would advance the state of the art of oxygen, hydrogen propulsion system seal. A total of 19 materials were evaluated, with 14 being tested at least once during the program. You can see here the schema of the test system adopted in this project by NASA. Regarding the test of the valve, that is encapsulated here in a jacket. And the test is performed with the injection of valve of the hydrogen, liquid hydrogen, in this part of the jacket, and flow the helium inside to the valve. Okay? And the test in this second part if there is some leakage of the seat. This is the original drawing for the project by NASA in 1960, 54 years ago. Okay? There are some other details about the test. The thermocouple were welded in the bottom of the valve in order to grant the temperature and to check and control what happened inside to the jacket. And this is the test procedure adopted by NASA. You know, the test procedure for liquid hydrogen test is not written, it's not so diffused today. It's not possible to say today what is the specific procedure adopted to test one valve in hydrogen condition. And this is the mother of all procedures, maybe, about this specific task. Okay? You can read the situation. One detail, the term zero leakage is used in this context, measuring the absence of leakage for 5 minutes in this part of the system. This is the second part of the procedure. You have to cycle the valve for 100 times, and some other step of the procedure, and finally you have the measurement in order to understand what happened. So, our association VALVEcampus, together the cooperation of 4 partners, DuPont, Switzerland, Fluor Seals, Fluor 10, and Victrex, decided to spend some time and money in order to analyze and verify the behavior of the polymers under LH2 condition. And the objective of the investigation is to measure the mechanical behavior of different plastic at the condition of 4 Kelvin. The material tested has been 2 sets of polyimide material, and 3 sets of PIC material, and 1 PCT-FE material, with the proprietary formulation of the companies that participate to the project. Comprehensively, we tested 72 items, 48 in order to have the benchmark at room temperature, with the calculation of the modulus and the compression strength test value and the compressive modulus. 24 items were tested at the condition of 4 Kelvin. 4 items for all material listed in this list. This is the explanation about the test. When you test in compression, you have to change the result in order to avoid to read the deflection of the machine and other interferences that can affect the final value and the result of the material. Practically, it's been the original line is this one, the green line, and after correction, the line moves back. This is. And this is an explanation of the machine used for this kind of test. It's a special machine able to give the compression in a tank where is the liquid hydrogen. And finally, we have the result. What is interesting in this map? You can see in this first column the max force adopted and the compression strength, the modulus, but really interesting is the value required to deform the sample at the quantity of 0.1%, 1%, 3%, 5% and more, okay? And you can note that there is a difference between the value, and of course this is not a definitive evaluation. The scope of the job wasn't to say this is better, is no better, but only to understand what happened at the temperature of 4 Kelvin. And finally, we check some deviation. The behavior of the material is different, and this map could represent the starting point for next evaluation and test and analysis that we want to perform in the future. I'm the president of the association. I'm not so experienced in this kind of application and test. If you want to have more further information about this test and the performance of the material, you can contact the persons that are listed here, okay? Representing the 4 partners of the project. Okay, that's all. Thank you.